welcome to the Remediators. Today we're going to be taking some moisture measurements and measuring pH and taking photographs and making observations of the growth and any changes in the condition that we could see in the soil here as these plants and fungi and microbes have been exposed to a variety of toxins. Primarily we're interested in seeing whether or not and which strain combinations that we're using here have the ability to degrade dioxin furans, although the soils in these containers are really a smorgasbord of a variety of organic and inorganic toxins. Anyway, what we're going to do today is we're going to take some moisture measurements. For that, I use one of these simple little electronic moisture meters. They're not very sophisticated, they're not very expensive either, but they're really accurate for being able to track over time how much water uptake is happening as these plants and fungi start to work on their growth and hopefully in degrading the toxins. So anyway, we have 3 strains of fungi. We have hybrid poplars here that have demonstrated a high tolerance to growing in saline environments and hostile environments that might be similar to the soil that they're being exposed to. And then a suite of bacterial microbes that are both growing inside within the poplars. They're called endophytes, as well as in the soil. And so they all work together, hopefully, to both degrade and deconstruct the molecules of dioxin and other organic compounds, as well as to put the inorganic ones that might not be soluble into a soluble form where these plants can take them up into their tissues. Anyway, we're going to start by taking moisture measurements. And when we're done with that, what we're going to do is we have a digital Bluetooth pH meter. And there's a sampling location in each one of these containers that I have marked. It's kind of hard to see. I can rotate it around here. I've marked them with a little plastic stake. Basically, there's a hole in each one of these containers that we will insert this into and take pH readings. And what we can learn from that is that changes in pH in the soil environment, as they're reacted with and upon by the plant, bacterial, and fungal growth, changes in pH can be an indicator of biological activity, trends over time particularly, like the measurements in the very beginning of a study versus in the end are probably the 2 most important. But by monitoring it over time, we'll be able to compile this into a data set that can be used to analyze the conditions and how they change, and maybe make some inferences as to what they mean as we go through the study. So that's the second thing we're going to do. The third thing that we do is we're going to record data, and the method that I've used here is I'll be showing you our whiteboard that we have on the wall. We have some columns on there that reflect each one of these containers, and temperature measurements that have been retained by this high-low reading thermometer. We record that, and by doing that, the trends that we see will then get expressed in graphs as we compile the data and analyze it for the study. So anyway, I'm going to get started here. I'm going to start measuring our strain number 1. We have it marked by color here. Here's the first container. I put this in. Okay, I'm getting a reading of number 7. when I left this the other day, I left it after measuring it in the morning with a reading of number 5. And so I watered with an amount that I thought was commensurate with what it needed, and it hasn't used much water. And so if we, I know you can't see this particular one in the video, but we have very little growth going on there, and it's an indication of lack of biological activity, that we have more moisture than what I expect we're going to get in our next measurement. Number 2 has a measurement of number 5. And that started out the other day with a measurement of 4. And what I'm shooting for here is ending up with a stable moisture content that's mid-range from 0 to 1 to 10 on this meter. So that would be in between 5 and a 6. And on this one we have a number 5 also. And we had, when we initially measured it the last time, it was also a number 5. So I'm starting to get the hang of how much water each one of these things needs, dependent upon the measurements that we see. So in between the measurement of any one given strain, I wash this thing off because I don't want to cross-contaminate these containers with a different strain of fungi and microbes that might be present in at work here. Okay. So our next one is strain number 4. We had a starting measurement the last time of a number 3, and oh boy, today there's a number 2. So this one is gobbling water. And as I look at it, the leaves of the plants, I don't know if you can see it here, but they look in pretty good shape. So we're here at about the right time. It's always better not to overwater, it's better to underwater. Better for the plants, better for the root growth, and there's still enough moisture in there that the fungi can be doing its work. Okay, our next one of that strain, same strain, number 4, we have a measurement way up high of number 9. And on this particular container, there's very little growth of the hybrid poplar. We started out with a 9 last time and ended up with a 9 this time. So nothing has changed very much. Now I need to find where the next one is. 4, 5. Aha, right down here. Now this one has a lot of plant growth on it. And we have a number 2 moisture reading. And that was a number 3 the last time. The plants look really good. So I think we're getting the hang of this. Okay, we need to go to the next strain, so we're going to wash our meter. Rinse it off, and the final strain I have marked in a different color. And that is a number 5. Where are you? And blue. You'd think I'd be able to find this by now. Okay. Right down here, we've got really good growth going on in this one, in our plant, in our poplar. And I've got a reading of number 3, and I started with the reading of number 5 the last time. So that's pretty good. It's using some water. And here's our next one. No, here's our next one here. Now this one has some really good growth too. We got a number 3 on it. And I think we'll measure this one, the last one, while we're here. And we got a number 4 on that. We started with a number 3 both times last time. So that's looking pretty good. Now we need to measure our controls. So what we've done here is we have 9 containers with soil from the toxic site at Willamette Cove. And then we have 6 controls, and each of those controls we have 2 replicates, one for each combination of fungal strain and poplar, and they're just lab soil. They're basically potting soil. And so the reason that we do this is we want to get an indication of a standard soil mix and be able to compare whether or not there are any interactions between these organisms that we can see in how well they grow in just a regular potting soil. And so anyway, I'll take those measurements. We're going to go kind of quick here. Here's the first one, and we don't need to wash this time because it's the same strain as the one we ended up with. It's a number 7. We had started with a number 8 last time when we measured. And here's the second one of that. And it's a number 8. And we had a number 10 last time. Not much change. Go to the next strain. We have a lot of plant growth here that we're seeing, and we have a reading of number 2. So it's pretty dry, and the plant looks pretty good. We started with a number 3 the last time on that. And here we also have some decent growth going on. Not quite as heavy, but it's growing well. Got a number 5 that we ended up with, and we started with a 5 last time. So we're tracking this good. We wash one more time, take 2 more measurements, and we'll go on to watering and then measuring pH. Number 3. Started with a 3 and ended with a 3. And we're up to a number 10, and there's no growth there, and we had a number 9 the last time. We're not going to water here this time. And we're going to look at our controls. And our soil controls are just uninoculated, unplanted soil. And so we have 3 of those, and I'll get the measurements from those. It's been kind of interesting watching them because there's a lot of germination of weed seeds that's happening. We're having grasses and other unknown weeds, known and unknown. Okay, this is number 2 for the first one. The second one is a number 5. And our third one is a number 6.